Hey class, welcome back to chapter 2, fractions. Today we are looking at the second half of exercise 2a, understanding fractions, and we'll be looking at improper fractions or mixed numbers. Now these are effectively the same thing. Previously we looked at proper fractions, so those were fractions where the numerator, the number up the top, okay, was smaller than the denominator or the number on the bottom. And we remember that with denominator or down, okay, it's down the bottom, they both start with D. Okay, today we are looking at fractions where the numerator, the number up the top, is bigger than the number on the bottom. So those are improper fractions, or we can express them as mixed numbers if we have a whole number and the fraction component to make the fraction component proper. We'll try it with an example and I'll show you what we mean. So what fraction of the shape is shaded? We have here two long rectangles, each split into 5 parts. Okay, the first triangle, all of it is filled in, which is one whole. And on the second rectangle, we've got 1, 2, 3 pieces out of 4, 5 total shaded in, okay? If we wanted to express this as an improper fraction, okay, so this is the mixed number because we've got both a fraction and a whole part, okay, and we write the whole part out the front. Let me make that one a little bit bigger so that it is the same size as the fraction. There we go. So we write the fraction next to it. So we read this as 1 3/5. We can also write that as, we had a total of 1, 2, 3. Yep. How many pieces total do we have? 1, 2, 3, 4, 5, 6, 7, 8 pieces total shaded. And each of these was broken into 5 parts. So 8/5. Okay, these are the same thing, which is why we put the little equal sign underneath it. 8/5 is the same as 1 3/5. We'll try one more example like this. This time, it's a little bit trickier. We have 3 circles, and they are each broken up into 4 parts. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I've got 3 pizzas, big pizzas, and I cut them each into 4 slices. How many slices total have been eaten? So the ones that have been coloured in. We've got 1, 2, 3, 4, 5, 6, 7 total. So 7 quarters. That's the same as saying, well, if I wanted to take this piece here and pop it in there, I now have 1 whole pizza and another 3/4 back over here. Okay, so here's 3/4 and here's the 1 whole, and I basically just add them together, and I can get rid of that when I smush them together. Okay, so these are the equivalent fractions. This is the improper part because the numerator up the top is bigger than the denominator down the bottom, and this here is the mixed number. Okay, they are equivalent, they mean exactly the same thing. This here was our improper, which I'm just going to write imp. Okay, we'll try a couple more examples, this time just with numbers. So I've got 3 examples for you. We're going to write each of the following mixed numbers as improper fractions. So to do this, we need to multiply the number at the front by the pieces on the bottom, because what this means is I've got 2 whole pieces broken into quarters, okay, and I've got all of those bits coloured in, plus an extra quarter, and you can always draw it out. We can count these. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. Mathematically, we could show that as, and I'm just going to have to write it underneath, I'm going to use square brackets to say this is my working and my thinking. Okay, we get 2 times 4, okay, which is 8, plus 1 quarters. So it's kind of like in brackets, and that would give us 8 plus 1 over 4. Okay, and of course the top stays in the brackets, and that's how we get that 9 quarters right there. Okay, so this is how to do it mathematically. This is if you'd like the visual. We'll try another. 7 3/8. So we're going to try going to this one straight away mathematically. We're going to start by multiplying 7 times 8, and then we'll add the 3. Okay, so we always add this bit and multiply the whole number at the front with the denominator. So 7 times 8, and the denominator doesn't change. 7 times 8 is 56. Still plus the 3 because I've only grouped this bit. Oh, we'll highlight the bit that I'm doing. Let's do that. Ugh, that's not my highlighter option. Okay, I'm only going to solve this bit to get to there. All right, 56 plus 3. So the whole numerator bit now is 59/8. Okay, so the denominator has not changed. You'll notice that this here has not changed the whole way through. It is exactly the same, and it shouldn't change. Okay, you should not have to change your denominator at this stage. Only the numerator is changing to make the mixed number part the improper. One more. 3 2/15. So again, we're going to multiply the 3 by 15. And then we're going to add the 2. Ooh, there should be 15. Okay. Divided by 15. So the 15 here stays the same. That equals 45. So 3 times 15 is 45. You are welcome to use your calculator to check it if you really, really need. Oh, that's not my highlighter. There we go. Okay, so that's the only bit that I've changed there. All right, still plus the 2. And then over 15, okay? We get 47/15 as our final answer. Now, of course, just as a final note, if I want to convert, let's make it 48/15 to a mixed number. The way that we do that is divide the 48 by 15. Okay, so 48 divided by 15 is going to give us still the whole number 3. And we put the remainder in the fraction. So the denominator stays as 15, but this time we'll have a 3 up the top. Okay, I've only got one more fraction part here than I did there. So to do that, we need to, let me grab another color pen to divide. So to convert an improper fraction to a mixed number, we need to divide this number, and then this here is the remainder, which I'm not going to fit the word remainder. That's okay. Okay, so the remainder goes up here, and the denominator, as always, does not change, at least not yet. We'll worry about changing the denominators later. So that's the same. Okay, but the remainder from your division problem now goes in the numerator of the fraction. So we have covered division before. If you're not sure on that, please refer back to exercise 1A. But as always, if you have questions, let me know, and I will speak to you all very, very soon to go over this in class. Have a great day, guys. Good luck with the work, and I'll see you all soon.